Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor, the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. So far, we are discussing the subject called Kinematics and Dynamics of Machinery, subject code of MR3451, under the regulation of 2021 for the semester, fourth semester for second year students. So in the last class, we have seen the various type of balancing, why balancing is needed. The basic concept we have seen, why balancing is needed in when it is in static condition as well as in dynamic condition also, why balancing is needed. What are the various disadvantages we have seen. When it is not balanced properly, what will happen? Automatically, it will cause vibration. Vibration leads to noise. Noise will have, again, it leads and tends to wear and tear of the system. It will spoil the entire system. So for that, we have to add the mass or removal of the mass. Based on that, we have to choose. So here, this is the syllabus of the balancing and vibration, that is static and dynamic balancing, balancing of revolving and reciprocating masses, and balancing machines. Here we can see one real-time application, that is a radial forces acting on a pump rotor. The rotor pump, we can see a impeller will be there, coupling end will be there, outboard end will be there. The two ends, it is mentioned over here. Journal bearing are there in the two ends. The hydraulic forces arising from the wing rings. Rotor mass weight, it is acting due to the gravity. Centrifugal force, that is in the closed loop, it is mentioned over here, elliptical shape. Centrifugal force due to unbalance, because that is mentioned over here. When it is not noticed properly, what will happen? The entire rotor will get spoiled. It will damage to the rotor. Hydraulic forces acting from the impeller, that force is also acting. Then hydraulic forces arising from the balanced drum. So if it is not balanced properly, centrifugal force will arise due to the unbalanced condition. So for this, balancing is needed. The following cases are important from the point of view, main subject point of view. What is that means? Balancing of single rotating mass by a single mass rotating in the same plane, balancing of different masses rotating in the same plane, balancing of different masses rotating in different planes. As this picture already we have noticed in the previous slides. The rotor that is rotating having a centrifugal force of F equal to m omega square r. Now we can see this balancing of several masses rotating in different planes. Mostly in examination point of view, different planes the students must study. Same planes is also okay, but most of the question they will ask from masses rotating in different planes only, not in same plane. So for that, the students have to study this in different planes. So now we can notice here, when several masses rotate in different planes, the centrifugal forces, in addition to being out of balance, also produce coupled. This is one important point. Then a system of masses is in dynamic balance when there does not exist any resultant force as well as resultant coupled. This is, we can see it is in dynamic balance. Both forces and couples are analyzed analytically or graphically. We have to make an analysis on this. Here we can see the diagram. One rotor shaft is there, two masses are there. We can see it is M1 and M2. A rotor is rotating with one angular velocity omega. The masses which is placed at a radii of rotation, that is R1 and R2. Now what is the centrifugal force that will be acting over here means M1 R1 L, so I omega square equal to M2 R2 I omega square. This is one basic sketch it is given. So based on the previous slide, you will have one important problem, very easiest problem for your reference, which I took. A shaft carries four masses in parallel planes A, B, C and D in this order. Masses at B and C are 18 kg and 12.5 kg respectively. Each has a eccentricity of 6 centimeter. The masses at A and D have an eccentricity of 8 centimeter. Angle between the masses at B and C is 100 degree and that between B and A is 190 degree. Both angles measured in the same sense. The axial distance between the planes A and B is 10 centimeter and that between B and C is 20 centimeter. If the shaft is in incomplete dynamic balance, then determine masses at A and D, distance between plane C and D, angular position of the mass at D. Here we can see one sketch over here. The various masses that is placed A, B and C and D. Here we can easily notice the distance is clearly given. A and B is 10 centimeter, so that we can mark it in the sketch 10 centimeter. What is B and C? Is nothing but 20 centimeter. That also we will notice that, and we will mark in the sketch. That is the first sketch that is shown in the right hand side of the slide. Then the end view, when seeing from this side view, we can see the various masses are placed like this. What are the various masses? Masses B, C and A. And angle is also, we can notice that 190 degree. Then 100 degree, that is B and C is nothing but 100 degree. Where is 190? B and A is 190. And we have to mark the angle and various kilogram masses also we have to mark in the sketch for your easy understanding. Then we can see in this left hand side lower bottom we have one tabular column. Why this tabular column is needed means, first you have to mark all the values in the tabular form in order to get the two polygons. One is force polygon and another one is coupled polygon. For this tabular column is needed. So what are the various columns? Means we have the planes in the first column, mass, then radius, force, distance from the reference plane and the coupled. Then we are having force is nothing but kilogram centimeter. Distance from the reference plane is L, having a measurement of centimeter. Couple is nothing but MRL, kilogram centimeter square. Now it is noticed various values. What are the various values? Means radius it is given 8 MA and the distance is 0, 0 because MA is a starting point, it is having no distance. So 0, 0. Then B is followed by 18 is given in the problem. Radius is also given. Then 108 we have to multiply the M into R. You will get 108 and the distance from the reference plane is 10. It is given in the problem. Then we have to multiply MRL. You will get 1080. Then for the C again followed by 12.5. Radius is 6 given in the problem. Kg of that mass C is nothing but 75. Then it is not 75. 12.5 into 6 you will get 75. That is MR. Then distance from the reference plane is 30 because 10 plus 20 it is 30. Then again multiplying the three columns M or L, you will get means 2250. Then MD we don't know, only we know the radius of rotation 8 into MD, LD we don't know. Again unknown value 8 into MD into LD. These are the two polygons you will get based on this tabular form only. Already two unknown is there. How you will get two known is there. How will get the unknown? The closing side of the polygon you will get the unknown. That is 2313 kg centimeter square. Again force polygon. Once you are getting this value, substitute in that to get the force polygon values. Then force polygon 8 MD equal to 63.5 kg centimeter. 8 MA equal to 78 kg centimeter. Then these are the various measurement values. From the force coupled by measurement, you will get 8 mdl ld equal to 2003 kg centimeter square. Upon simplification, you will get theta d equal to 203 degree. From the force polygon by measurement, 8 md equal to 63.5 kg centimeter, 8 ma equal to 78 kg centimeter. Upon calculation, you will get md equal to 7.94 kg, ma equal to 9.75 kg. Then ld equal to 289 divided by 7.94, you will get 36.4 centimeter. Now balancing machines. Balancing machines are used to indicate whether the part is in balance or not. As we already seen that based on the effect of the centrifugal force, as a high dynamic forces, it will cause a damage to the entire system. The types of balancing machines are nothing but static balancing machine, dynamic balancing machine. Here we have a glimpse of the images which I noticed in the right hand side of the slide. So this is a reference which I used for preparing this content of these videos. Kindly go through these references. Thank you for your kind attention, students. In Unit 5, we have seen the two videos for this balancing of masses. In upcoming videos, you will see the basic introduction part of the vibration, followed by some derivation and some problems. So please subscribe the channel. Please share this video to your friends. So we will see in the upcoming video. Thank you, students.